Space Agency steht. Das wäre wahrscheinlich einfacher.
Verschlusszeiten auf 500. Ja, weil es total Lichtstreifen bringt. Ja, das geht 500. Ja. Das ist jetzt ein Tausendstel. Ja, das sind 200. Aber das, was ich üblicherweise Tausendstel erwähnt habe. Habe ich denn? Was hat die von so eine Antiquika. Achso, das muss ich mal recherchieren, da habe ich jetzt keine Zeit für. Ah ja, Klimaplatzierung.
Ich habe es noch nicht ausprobiert.
Danke. Ich bin jetzt schon happy. Da hat sich der Besuch ein bisschen.
War eine super Sache. Danke. Also eigentlich sollte es umgekehrt sein. Genau. Also die wollen ja jährlich machen, aber ich glaube, das muss ja überlegen. Wenn die nächstes Jahr eine Kinder haben.
Sehr merkwürdig.
Da fehlt noch der Digital.
Sehr merkwürdig. Trotz Klimawandel.
Das vergessen viele.
Und das
Hier gibt es übrigens noch Ausschnitt vom Space Agency.
Also ich jetzt eine längere Zeit
längere Zeit ist besser, wenn die besser ist.
Ja, genau. Ganz still.
Genau.
Nee, wunderbar. Wer schön? Kann man ja gedacht. Wir sind schon an der Lautstärke noch nicht. Das heißt, wir müssen nicht beheben.
Wichtige Information. 20 plus
Okay.
Also nicht wichtig gestellt.
Alles gut. Sehr geehrte Damen und Herren, herzlich willkommen zum Pressebriefing heute zur 9. Space. Nochmal.
Sehr geehrte Damen und Herren, herzlich willkommen zum Pressebriefing heute zur 9. Space Debris Konferenz der ESA in Bonn in Zusammenarbeit mit dem DLR. Ladies and gentlemen, welcome as well, colleagues of the media who are watching us online. We are here today at the World Conference Center in Bonn in Germany for the 9th European Space Debris Conference. My name is Bernhard von Weihe from ESA Media Relations. We're having a local press conference here with mostly German-speaking journalists, so you will forgive us if parts of the press conference will be in German, but parts will be in English as well. We are also very pleased to have a couple of international journalists present today. Of course, we're a European organization, and it's an event with 500 participants from 40 countries, so really we want to have this global, so English, of course, anytime welcome too. We have two colleagues from the media relations team or from the communications team, Paulina Huard in the background if you need interviews afterwards, and Daniel Skuka, who is a technical communication expert from ESA as well, was present here. We have an audio split box for radio and TV journalists. You can get the audio signal there, and afterwards you also have the possibility to ask questions. We have a really distinguished high-level panel here today from ESA, from partner organizations and DLR Space Agency. And now I would like to give the floor to Dr. Holger Krag, the program manager, and you can start. I think you have a little presentation as well you want to show in English. If you can switch to the PowerPoint, please. Thank you.
Many thanks, and warm welcome also from my side. Indeed, I wanted to use a few minutes to debrief you on the status of the space environment. If you can move to the next slide. What you see here are all human-made objects in space that have a minimum size of 1 meter. That's about 10,000 objects. If you move, next slide, please. What you see here are all objects that have the minimum size of my smartphone here. That's important because these 40,000 objects, that's what we're talking about, these are the objects that are tracked from ground. And these are the objects that we know by name and by position. And we can even predict where they will be tomorrow. And that's quite important because we can avoid collisions by flying our spacecraft around them. If you move to the next, you will see everything above the size of a cherry, 1 centimeter. 1.1 million is our estimate. We cannot see them anymore from ground, but they are good model assumptions. And 1.1 million is a very good estimate. And last but not least, you see everything above 1 millimeter. 130 million objects are out there of this size. And you might ask, 1 millimeter, is that still something to worry about? And unfortunately, yes, because if you move one further, you see an example, a real-life example that has hit us 10 years ago. Unforgettable moment in the ESA Space Operations Center where Sentinel-1A, one of our environment satellites that we operate for the European Commission, has been hit into the solar array by a piece of just 2 millimeter. The piece was too small to be seen, no chance to avoid it in any way. But the impact has generated fragments that are now visible from the ground. And you won't believe, but these fragments have already triggered collision alerts with other objects, even ESA objects. Now, just this morning, a message came in that the very same satellite, which is still operational, will have to do a collision avoidance maneuver this evening to avoid a piece of an upper stage that was produced about 2 years ago. And now you understand how entangled the problem of space debris is. If you move to the next slide. Today we are releasing a report that gives statistics on the use of the space environment. And one of these statistics refers to the suppression of explosions, fragmentation event. It's hard to believe, but we do have several hundred events in the past where space objects literally break up. That is because of residual energy on board, fuel, pressure in tanks, even charged batteries. And you see here there's an average of 10 per year. And the frightening news is that unfortunately this number doesn't improve a lot over time. Of course, to be fair, many of these objects breaking up are already quite old, but it's also newly launched objects that still tend to break up. And that leads to the situation we are having now. Next one, please. This comes in a combination with a much more heavy use of space. And I think the use of space is what we want to do. We want to see spaceflight. But the combination of not fully mastering space debris prevention with more spaceflight is, of course, something that we need to look at very closely. Next one, please. And to explain, because it's very hard to translate the situation into actually risks, we try the following. For a typical Earth observation mission, which is tracking the ground, which is plotting the ground, you will see on the left a box, and that box shows every white square in this box is a day where we have to do a collision avoidance maneuver and therefore lose data. We cannot do the mission during a collision avoidance maneuver. When we continue and extrapolate the trend that we are following right now with our current behavior, if you hit once more, next one, we would end up with a situation where our yearly calendar would be full of maneuvers and we would be hardly having any time to do a proper mission. This is definitely to be avoided. And the debris prevention measures that we are putting forward, they are aiming at containing the trend to the lower blue curve, giving us an acceptable environment even after 100 or 200 years by. But for this, we need to invest in technology. Regulation is important. Technology to fulfill this regulation, that's even more important. We are having a problem of lack of robust systems that can actually implement the rules and guidelines that we are asking. Making a system safe to prevent explosions, making a system reliable to be disposed after the end of operations, or even to get an object out of space after it was stranded. This is the technology that we are putting forward in the ESA programs like space safety, and this is what we need in order to get a stable trend. Thank you very much.
Thank you very much, Holger Krag. And now we have the pleasure to have the Director General of European Space Agency, Josef Aschbacher, on the panel, please. The floor is yours.
Thank you. Thank you, everyone. I think you have seen very clearly and very nicely on what the size of the problem is and what needs to be done. So I'm not further elaborating on any of these numbers, but the message is crystal clear. Space debris is a problem, and we have to do something about it. And this is why, especially also as Director General of ESA, in very close cooperation with Holger Krag, with Rolf Denzing and the teams in charge of space safety, we have discussed what do we need to do and what can we do in order to mitigate the problem. I should make it clear, we are not a regulatory agency, we are a technical agency. We are not doing regulation on space debris. This is for other, for member states or the European Commission or other entities to do, but we are a technical agency, and that's why we look into technical aspects. On one side, and this is something we have done together with the member states. Thank you, Walther, representing Germany in the ESA Council, but also the other ESA member states. They have asked me at the Sevilla Space Summit, which was in November 2023, to put together a zero debris charter, which has been introduced before, which is a very simple mechanism where we invite those who sign up to the charter on a voluntary basis to commit that they will bring space debris, that means their satellite, at the end of its life out of the orbit within 5 years. And this is a very important step. It makes not only good sense, but it's something that is absolutely necessary, as just shown here very clearly. What I have done also within ESA is I've instructed my project managers within ESA that any future satellite of the European Space Agency will have to follow the same principles as expressed in the charter. That means built in a way that at the end of its life, we can bring it out of orbit within 5 years. This requires technical developments, the way how a satellite breaks up when it re-enters into orbit, the fuel that needs to be on board in order to deorbit it actively, but also take measures in case we cannot deorbit a satellite by its own, that we can grab it and take it out. And there we have launched a project. Germany actually is leading this project among the ESA member states, where we have literally an arm that embraces an object, in this case an old satellite that doesn't function anymore. It's 4 arms, so it's like an octopus with 4 arms, grabbing it and taking it out of an orbit where it could collide with others. So you see we are working on different activities. It's really the technology part that we bring together, where we would like to also engage industry, and these are partners of our Zero Debris Charter through the technical handbook that we are publishing as well. What can be done? How can we develop technology, then hand over to industry, which they can use to mitigate the problem and to really address it. So this is the role of ESA. Actually, I can say that this Zero Debris Charter and our technical activities are highly appreciated by the international community in the US, in Japan, in Australia, in many countries. And this is something that we would like to promote further. It's a priority for us to make sure that our orbits are kept clean. And this is what we are doing in Europe, but also globally, because space by nature is global.
Okay, thank you very much, Josef Aschbacher. And now I'd like to hand over to Dr. Walther Pelzer, Director General of the German Space Agency at DLR, auf Deutsch, auf Englisch, wie Sie wollen. Bitte schön.
Yeah, thank you very much. As already mentioned, I was asked to answer in German. Nevertheless, if there are some question in the audience in English or in the web, I'm more than happy to also answer in English. Es wurde gerade gesagt, die ESA entwickelt exzellente Technologien, um der Problematik, und das ist eine sehr, sehr ernste Problematik, das Space Debris zu entfernen. Nichtsdestotrotz, immer aufräumen ist gut. Besser ist, wenn es gar nicht erst sozusagen schmutzig wird. Und Deutschland hat deswegen das Thema Space Traffic Management, die Frage, wie verhalten wir uns im Orbit, wie sehen die Regularien aus, auf die internationale, auf die europäische Ebene gehoben, als wir die Präsidentschaft in Europa inne hatten. Das heißt, dass wir auf der einen Seite schon mal die Regularien vorbereiten, damit wir endlich nicht mehr First Come, First Serve, wir nennen es so ein bisschen Wild-West-Manieren im Orbit haben, sondern dass wir tatsächlich uns über Regeln einigen, dass wir in Zukunft den Weltraumschrott tatsächlich verhindern können. Auf der anderen Seite arbeiten wir international mit der ESA, mit den Vereinten Nationen, aber auch mit der Europäischen Union zusammen, um Technologien und Fähigkeiten natürlich weiter zu entwickeln. Das sind zum Beispiel auf der nationalen Ebene dann unsere Tätigkeiten, die wir überwiegend in UDEM durchführen. Das ist eine einzigartige Einrichtung, wo unter einem Dach das Weltraumkommando der Luftwaffe und unsere Truppen, also unsere Leute von der Raumfahrtagentur zusammenarbeiten. Wir analysieren die Daten, geben Bewertungen ab, geben die dann weiter an die Kollegen vom Weltraumkommando, die dann die entsprechenden, ich sag mal, Maßnahmen ergreifen bzw. durchführen. Das heißt, hier agieren wir aktiv, um eben Warnungen herauszugeben. Wir machen aber auch mehr. Wir haben ein Radar, das nennt sich Gestra, entwickelt. Ein Radar, das sozusagen einen Zaun aufspannt mit 256 Arrays, mit dem wir auf der einen Seite sehr schnell erkennen können, wenn im Low Earth Orbit ein Debris durch diesen Zaun fliegt, und gleichzeitig dann dessen Orbit aufzeichnen, um diese Information dann international zur Verfügung zu stehen. Das ist einmal innerhalb der europäischen EU-SST-Tätigkeiten, da wird ein Katalog erstellt. Diese Aufgabe obliegt Deutschland, den Kollegen und Kolleginnen in UDEM, die aus ganz Europa diese Informationen zusammenführen. Und wir gehen auch weiterhin davon aus, dass wir dann diesen Katalog in den internationalen Katalog, der jetzt momentan hauptsächlich aus den USA kommt, beigefügt wird. Das heißt, wir versuchen, unsere Sichtbarkeit, die wir vom Orbit haben, auf der einen Seite zu verbessern, aber auf der anderen Seite da auch unabhängiger von internationalen Partnern, hier speziell natürlich den Amerikanern, zu werden, die uns sehr viel Informationen da geben. Auch das ist ein Teil, dass wir die Unabhängigkeit im Bereich der Raumfahrt steigern. Wir brauchen aber mehr als diese Sensoren, die wir momentan haben. Das ist der Grund, weswegen die Deutsche Raumfahrtagentur aktuell auch in 3 Laser-Ranging-Sensoren investiert, die im Jahr 2027 aktiv werden. Damit werden wir weitere Daten, sehr viel präzisere Daten dann aufführen, die auch in die entsprechenden internationalen Kataloge gehen. Ziel ist es allerdings, sowohl von Deutschland als auch natürlich unsere Tätigkeiten der Deutschen Raumfahrtagentur innerhalb der Vereinten Nationen, zu einem Regelwerk zu kommen, damit Raumfahrtmüll nicht mehr in der jetzigen Art entsteht. Wir müssen dazu kommen, dass wir Raumfahrtmüll vermeiden und nicht genannt ist bisher zum Beispiel die Ariane 6, oft gescholten, weil sie nicht wiederverwendbar ist, aber die Oberstufe hat eine Vorrichtung, damit die Oberstufe gedeorbitet werden kann. Also hier ist aus meiner Sicht ein Schritt in die richtige Richtung von vornherein gemacht worden, dass man einen Launcher entwickelt, der mehrere Orbits zwar adressieren kann, aber am Ende seiner Mission keinen Weltraumschrott hinterlässt. Das ist, glaube ich, ein wichtiger Schritt und ein Zeichen dafür, was Josef Aschbacher eben schon dargestellt hat. Wir wollen sicherstellen, dass wir im Jahr 2030 mit unseren Raumfahrtaktivitäten in Europa, aber auch in Deutschland keinen Weltraumschrott hinterlassen.
Okay, vielen Dank, Walther Pelzer vom DLR. Thank you very much. Vielleicht noch zwei kurze organisatorische Hinweise. Hier zwei Kollegen noch aus dem Communications-Bereich. Martin Fleischmann vom DLR, wenn Sie DLR-bezogene Anfragen haben, und Daniel Skuka von ESA Communications, hatte ich vorhin schon kurz erwähnt. Und jetzt würde ich weitergeben an Professor Carolin Frueh. You want to do it in English or in German, as you wish. The floor is yours, please.
Hallo. Ich komme von der Purdue University und bin auch der Chair vom COSPAR PEDAS. Und wenn man meine Folien bringen könnte. Slides, please.
Kommt sofort.
Eventually. Das ist natürlich sehr schade, weil ich das gerne komplementiert hätte, was der Herr Krag in seinem Film hatte, weil ich da auch... Stein hat... Stein hat die Slides bekommen.
In space, we are also flexible. So let's swap for a moment. We'll find those slides. If we can start with Professor Camilla Colombo from the Politecnico Milano. I have your slides. They're in the regie. She will start, and then when she's done, we will find your slides, and you can make the presentation. That's probably the best. So you can stand here and explain your presentation, and I will look for the slides.
Good morning, everybody. Next slide, please. As Holger Krag introduced, space is now offering our humankind many services, and for monitoring of the Earth atmosphere, the Earth surface, for telecommunication, for geolocation. And going to the next slide, as recognized by the UN, space missions are helping us achieving the Sustainable Development Goals. Next. However, as it was already said, the many number of space mission is creating this space debris problem. And if you look for a moment at the going back at the graph that is showing the evolution of space objects number and fragment number in time, this trend has a very similar behavior to other environmental issues of our Earth, our biosphere. For example, like carbon dioxide, tropical forest loss, ocean acidification. And that exponential graph is the graph of any environmental problem. So we can see the space debris problem as another environmental problem. and it's going to be possible to stop it only if a change of behavior by space operator, but also a new development in technologies is going to be possible. And in the next slide, I will try to highlight what are the challenges that researchers worldwide and in Europe are facing with actually a very great contribution from the European Space Agencies, from space agencies such as DLR and from the EU Commission. First of all, there is a very important challenge of monitoring and modeling space debris, because space debris are out there and we are down here, and therefore we'll rely on long-term evolutionary model. To explain this, they are very similar to climate models, and so we do very similar modeling as climate scientists. And the issue is that space debris models are affected by many uncertainties due to our poor knowledge of some phenomena, but also, for example, the solar activity, but also due to the fact that the future of space debris in the future of 200 years depends on launch traffic, and we need to understand how to forecast the future launch traffic. So the first challenge is how to enable this uncertainty modeling into space debris modeling, how to develop a predictive model of the future evolution of space. The second challenge is imagine that we have a very clear model of the space debris population. How can we control it? How can we control this system over many, many years? And at the moment, space traffic management is taking care of space operation on the short term, weeks to months. But we need to understand how to harmonize space traffic management, so short-term mission operation with the long-term sustainability of the space environment. And going to the next slide, how to do that? We need to understand how to transform all the technical action that are being devised, such as active debris removal, limiting of explosion, collision avoidance maneuver, end-of-life maneuver to remove the spacecraft from the orbit, how to harmonize all those control action and how to translate them into policies, and how to make policies and law very fast, very reactive to this very fast environment.
Okay, thank you very much. We're getting the slides, we're on it. But I propose that we now also start with, thank you, we start with the additional astronautical perspective to the topic of space debris and international cooperation. By the way, I should mention we have two astronauts in the room, Matthias Maurer from the European Astronaut Center in Cologne, and Thomas Reiter, also a very experienced ESA astronaut and former board member of ESA, who has a lot of things to say about the topic of space debris as well. Thomas, the floor is yours.
Ja, vielen Dank. Guten Morgen, meine sehr verehrten Damen und Herren. Ein paar Worte zu dem Thema astronautische Raumfahrt. Sie können sich vorstellen, dass all diese Raumfahrtrückstände, über die wir heute gesprochen haben, in den nächsten Tagen hier mit den Fachleuten sprechen werden, auch eine Gefahr für die astronautische Raumfahrt darstellt. Der Matthias kennt das aus eigener, ich möchte fast sagen, leidvoller Erfahrung, denn zu Beginn seiner Mission musste die Crew direkt in Deckung gehen, weil als Folge eines russischen Antisatellitentests die ISS in so eine Debriswolke gewissermaßen reingeflogen ist und Gefahr bestand. Die internationale Raumstation ist seit über 20 Jahren im Orbit. Seit Ende der 90er Jahre, als der Aufbau begann, musste sie in dieser Zeit über 35 Ausweichmanöver fliegen. Das ist im Vergleich zu der Anzahl von Ausweichmanövern, die unsere Satelliten machen müssen, vergleichsweise wenig. Das entspricht ungefähr 1,5 solcher Manöver pro Jahr, wenn man es mal so über die Zeit mittelt. Das ist nicht immer so gleich verteilt. Es gibt mal Jahre, da müssen 3 geflogen werden, dann ist tatsächlich mal ein Jahr, wo kein Manöver geflogen werden muss. Der Grund dafür ist in allererster Linie natürlich, dass wenn es hier ein Kollisionsrisiko mit aktiven Satelliten gibt, die natürlich ausweichen. Also Vehikel mit Menschen haben Vorfahrt. So lässt sich das einfach zusammenfassen. Jetzt gibt es dort oben natürlich auch Fälle, wo irgendwelche Objekte sich mit der Bahn der ISS kreuzen, die nicht manövrieren können, die einfach tote Materie sind, und in dem Fall muss dann eben die internationale Raumstation ausweichen und tut das. Das ist für so einen riesigen Komplex, der über 400 Tonnen an Masse hat, natürlich etwas umfangreicher oder etwas umständlicher, kostet mehr Treibstoff. Funktioniert aber sehr gut. Wenn irgendwelche Versorgungsraumschiffe dort oben gerade angedockt sind, dann führen die diese Manöver durch. Wäre keins angedockt, könnte die internationale Raumstation auch mit eigenen Mitteln. Im russischen Segment ist das gewissermaßen technisch implementiert, durch Zündung von 2 Triebwerken so ein Ausweichmanöver machen. Nur damit Sie eine Vorstellung haben, das sind also nicht riesige Manöver, sondern da reichen manchmal nur Geschwindigkeitsänderungen von wenigen Zentimetern pro Sekunde, um so ein Kollisionsrisiko so weit zu verringern, dass es eben keine Gefahr mehr darstellt. Die internationale Raumstation selbst ist geschützt vor Objekten bis zu einer Größe von ungefähr 1 Zentimeter. Das heißt, die hat also eine Panzerung, ist nicht der richtige Begriff, aber es sind eben Maßnahmen getroffen, dass man bis zu dieser Objektgröße, dass die nicht die druckbeaufschlagten Module durchschlagen können. Soweit, so gut. Die Objekte, die man mit Hilfe von Radaren und von optischen Systemen erfassen kann, die haben natürlich auch nur eine gewisse Detektionsgröße, und die geht so ungefähr runter auf 10 Zentimeter, wahrscheinlich ein bisschen weniger. Und daraus können Sie sehen, dass es einen Bereich gibt zwischen der Größe, gegen den die ISS geschützt ist, zwischen der Größe, die man entdecken kann und dann ein Ausweichmanöver fliegen kann. Also da gibt es eine Grauzone, die ein gewisses Risiko darstellt, und deshalb müssen die Crews an Bord natürlich auch für diesen Fall gerüstet sein, dass ein Treffer stattfindet und eine Dekompression stattfindet, und das trainieren die Kolleginnen und Kollegen regelmäßig, nicht nur bevor sie auf die Mission gehen, sondern auch wenn sie oben sind. Es gibt bestimmte sehr kritische Notsituationen, dazu gehört die Dekompression, beispielsweise durch so einen Treffer. Und da können Sie sich vorstellen, muss jeder genau wissen, was zu tun ist, und deshalb trainiert das Matthias und die Kolleginnen und Kollegen, auch während sie dort oben sind, weil das sind so diese Momente, wo man keine Fehler machen sollte. Das kann man so sagen. Gut, für die Zukunft ist es natürlich auch wichtig, dass wir immer so diese astronautische Raumfahrt ein bisschen im Auge haben. Sie wissen, heute ist gerade ein Raumschiff gestartet mit der ersten deutschen Astronautin. Die sind allerdings auf einem anderen Orbit, auf einem polaren Orbit, aber die sind natürlich genauso in dem Bereich, in dem solche Kollisionen stattfinden können. Vielleicht abschließend noch die Anmerkung, die internationale Raumstation fliegt in der Höhe von 400 Kilometern. Da ist die Dichte von solchen Raumfahrtrückständen nicht ganz so hoch. Die größte Dichte ist in größeren Höhen so um die 800 Kilometer und darum herum. Aber natürlich alles, was sich dort oben bewegt, kommt irgendwann mal runter, ja, wird niedriger, 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 bevor es dann irgendwann mal in die Erdatmosphäre eintritt. Und deshalb ist es natürlich auch aus Sicht der astronautischen Raumfahrt, insbesondere auch mit den Plänen, die wir für die Zukunft haben, Exploration jenseits des niedrigen Erdorbits Richtung Mond und weiter, wichtig, dass wir uns dieses Themas annehmen und eben alles dafür tun, wie Sie bereits gehört haben, die Ausbringung von solchen Raumfahrtrückständen zu minimieren, das, was dort oben rumfliegt, was größer ist, aktiv zurückzuholen und eben gemeinsam in Zukunft eben auch uns Gedanken machen über Regeln, wie wir dort oben, also gewissermaßen Verkehrsregeln, wie wir dort oben miteinander umgehen. Und das ist eben auch Teil dieser Konferenz bis Freitag, um hier die nächsten Schritte zu unternehmen. Vielen Dank.
Vielen Dank, Thomas Reiter, ESA-Astronaut, ehemaliges Vorstandsmitglied. So, jetzt noch ein organisatorischer Punkt. Der Generaldirektor hat, glaube ich, jetzt noch andere separate Termine, müsste woanders hingehen. Aber wir haben auch im Bereich Space Safety noch einen weiteren ESA-Vorstand, den ich noch nicht vorgestellt hatte. Dr. Rolf Densing sitzt hier in der zweiten Reihe, ESA-Direktor für Missionsbetrieb und Space Safety, der eben dann auch, wenn der Generaldirektor jetzt rausgeht, diese strategisch-politische Dimension perfekt abdecken kann. Und jetzt, Frau Professor Frueh, wir bitten um Nachsicht. Wir haben Ihre Slides gefunden, die sind fertig und Sie sind dann. Sie haben das Wort. In English, in German, as you wish. Thank you.
Dankeschön. Ja, wir haben viel über den Weltraumschrott gehört und bis vor kurzem war der Fokus wirklich im erdnahen Raum, aber das greift zu kurz. Ich habe jetzt hier ein paar Missionen mitgebracht, und wir haben auch viel gehört, dass immer mehr auch von dem Traffic in den sogenannten cislunaren Raum, also in den Bereich zwischen der Erde und dem Mond, den Mond mit eingeschlossen geht. Wenn wir eins weiterklicken, dann sehen wir hier das Komplement zu, was Dr. Krag gezeigt hat. Wir sehen in Rot, das waren die ganzen Objekte, die er gezeigt hat, und dann in Grün sehen wir, was momentan schon weit über den geostationären Ring momentan im Orbit ist. Das ist auf dem US Space Track Katalog basierend. So in Grün, das sind die ganzen Objekte, die über dem geostationären Ring sind, in diesem Raum zwischen der Erde und dem Mond. Und wir sehen, diese vermehrten Missionen haben natürlich auch einen Einfluss. Das sind zum einen die lunaren Einschläge. Ich habe da einfach ein Beispiel hier mitgebracht von Chinas Chang'e Booster. Noch nicht weiter, bitte. Immer noch auf der folgenden Slide bleiben. Danke. Und eben auch beinahe Kollisionen von dem LRO und dem Chandrayaan-2 Orbiter. Und da müssen wir uns klar sein, das ist jetzt nicht die Frage, ob wir Fragmentierungen und Kollisionen in diesem Bereich haben werden, sondern einfach nur wann. Das wird stattfinden. Jetzt bitte die nächste Folie. Genau, und wenn wir das sehen, wenn wir Fragmentierungen oder Explosionen in diesem Bereich haben, die Objekte können dann wirklich überall hingehen. Die können zurück zur Erde gehen, die können in den erdnahen Raum gehen, into Low Earth Orbit oder in den geostationären Bereich. Sie bereiten sich aber auch in dem Zwischenraum aus und sind dann einfach im Weg sozusagen. Also wir haben hier ein paar, Sie sehen das in dem Video, ein paar Simulationen, die wir gemacht haben. Oben ist das die Lyapunov-Region, unten ist das NRHO, da wo das NASA Gateway hingeht. Zugleich müssen wir sagen, zum einen fehlt uns da einiges noch an Forschung, aber wir haben auch sehr wenige Regularien. Wir haben die Outer Space Treaty, aber selbst solche einfachen Mitigation Strategies, die wir aus dem erdnahen Raum kennen, wie die Passivierung von Oberstufen und so weiter, da gibt es noch keine Regulierung, noch keine, nicht mal Recommendations in dem Bereich. Und während das eigentlich eine Chance wäre, eben nicht diese Tragödie des Allgemeinguts, die wir vom erdnahen Raum kennen, zu wiederholen, sind wir eigentlich schon im Hintertreffen, weil diese Missionen starten, die sind da, wir haben gesehen, wir haben schon viele Objekte auch in dem Raum und wir sind im Moment dabei, die gleichen Fehler, die wir im erdnahen Raum gemacht haben, mit dem Weltraumschrott dort zu wiederholen.
Okay, ganz herzlichen Dank, Professor Frueh. Thank you very much. Jetzt würde ich sagen, gehen wir die erste Q&A-Runde hier lokal. Gibt es erste Fragen? Kollege Skuka hat ein Mikrofon, ich auch. Zögern Sie nicht. Und wie gesagt, es gibt keine schlechten oder ungenauen Fragen. Wir arbeiten mit Ihren Steuergeldern und wenn Sie kein Experte sind, das ist absolut kein Thema. Uns ist sehr wichtig, dass Sie verstehen, worum es geht. Und wenn Ihnen Sachen unklar sind, bitte unbedingt melden. Ja. Bitte schön, wer hat die erste Frage? Of course, you can ask in English as well. I suppose the Dutch colleagues could follow the German okay, so please go ahead, you as well. Bitte sehr. Und sagen Sie dann noch, zu welchem Medium Sie gehören, dann können die Kollegen das ein bisschen einschätzen.
Hallo, Susanne Rolfing, Kölner Stadtanzeiger. Wenn ich es richtig verstehe, sind Sie sich des Problems bewusst und ganz gut aufgestellt in Organisationen, wo sich jetzt verschiedene Agenturen offenbar anschließen, dagegen vorzugehen. Ich glaube aber, ein Grundproblem ist ja, dass der private Sektor sich so ausweitet im Moment. Inwieweit sind diese privaten Menschen wie Elon Musk Teil ihrer Bemühungen oder Teil ihrer Verbände, die Sie da gerade gründen, um gegen dieses Thema Weltraumschrott vorzugehen?
Ja, man kann nicht unterscheiden nach dem Motto, ob es private oder institutionelle sind. Die Frage oder das Problem sind die fehlenden Regularien. Es ist tatsächlich die Problematik, dass keiner vorgegeben hat, momentan, wie lange Objekte tatsächlich im Erdorbit bleiben müssen. Momentan gibt es eine Regelung von 20 bzw. 25 Jahre. Das ist zu lang. Und wir müssen Regeln finden, um eben klarzumachen, dass das, was zum Beispiel die Ariane 6 kann, dass das alle Space-Objects machen, dass sie dann zum Beispiel nach End of Life innerhalb von einer gewissen Zeit gedeorbitet werden. Das kann aber nur funktionieren, wenn man allgemein akzeptierte Regeln hat, die zum Beispiel in den Vereinten Nationen abgestimmt sind und dann in nationales Recht überführt werden. Das ist notwendig, um das darzustellen. Es ist kein Problem von, ich sage mal, privat oder nicht privat, es ist ein Problem der fehlenden Regularien. Und Hintergrund dafür ist, dass sich eben viele, und das ist in der Tatsache eine private, ich sage mal, sträuben, in diese Richtung zu gehen. Denn die Lebensdauer und die Kosten, die durch das Deorbiting entstehen, sind immens. Und das ist ein Grund, weswegen dieses auf den ersten Blick doch so einfache Problem in der regulatorischen Umsetzung schwierig ist.
Another answer? Maybe in English for the online audiences?
I can only underline what you said. Indeed, if you look at the situation now, that's actually not the private that have caused it. It was that was the space traffic of the past, which was mostly governmental. So there's no good and bad, but of course, what we see with the privatization is an enhancement of the traffic. So a problem that we didn't master in the past now gets enhanced by having just more traffic. And we heard the answer. It's a lack of regulation, but I would like to add it's very much also a lack of technology, because if you look around, you don't see much bad will. You don't see people that say, I don't want to be clean. Everybody tries hard to do the best, not to leave debris behind, but it's just technically difficult. It's difficult to safely dispose a spacecraft after it has been 10 years in orbit. Imagine your car. After 10 years, you will have to do the biggest travel in the whole life of the car. That corresponds to what we do in space. Maneuvering a spacecraft out of space that it re-enters is a significant effort. And very often you find goodwill, but the technical system that simply fails to do that. And therefore, I believe we need to have regulation, but we also need the technology to implement this enhanced regulation.
Okay, andere Fragen im Raum? Bitte schön, Kollegin von Focus.
Ja, Sonja Fröhlich vom Focus Magazin. Unsere Pressekonferenz hat ja den Titel Experten befassen sich mit der wachsenden Bedrohung durch Weltraummüll. Ist es eine Krise? Ich habe die Antwort auf diese Frage noch nicht so klar vernommen. Ich weiß nicht, wer vielleicht sie beantworten möchte. Sind wir in einer Krise? Wie ernst ist die Lage?
Ich kann ja anfangen, aber ich glaube, die Antwort wird von uns allen klar sein. Der Begriff Krise ist meiner Meinung nach vielleicht nicht glücklich gewählt. Ich würde nicht sagen Krise, weil eine Krise ist wie ein Projekt, beginnt und endet so ein bisschen. Wir haben hier ein massives Problem. Wir sind in ein massives Problem gelaufen und wir haben im Low Earth Orbit damit angefangen und wiederholen es jetzt auch in anderen Orbits. Also insofern ist es gar keine Frage. Ich habe es eben in meinem Vortrag sogar als Hidden Grand Challenge, also große gesellschaftliche Herausforderung dargestellt, denn unser Wohlstand und die Art, wie wir leben, ist inzwischen so sehr von der Raumfahrtinfrastruktur abhängig, dass wenn wir es nicht schaffen, Raumfahrt nachhaltig zu machen, im Sinne von langfristig zu ermöglichen, wird das eine extreme Herausforderung sein, denn dann werden uns die Services, die wir von Raumfahrt haben, die wir täglich nutzen, die uns erst ermöglichen, dass wir zum Beispiel von unserem fossilen Energieträger zu nachhaltigen Energieträgern wechseln, dann werden die weg sein. Und deswegen ist es nicht eine Krise, wir haben ein massives Problem.
Okay, vielen Dank. Rolf Densing, vielleicht noch eine Ergänzung, auch jetzt konkret zum Beispiel, was in Darmstadt mit dem Satellitenbetrieb passiert?
Also zum Thema Krise, das ist ja so mit dem Weltraummüll, der multipliziert sich. Das ist wie eine Lawine. Und wenn man eine Lawine stoppen will, dann macht man das am besten, je früher, je besser. Und wir müssen heute anfangen, die Krise in der Zukunft zu verhindern, falls ich mich klar ausdrücke, weil die Population, die wächst rapide an. Sie haben die Grafiken gesehen, die Kollegen gezeigt haben. Und da besteht ja auch eine Wahrscheinlichkeit, dass die alle untereinander kollidieren und dann in einem Lawineneffekt ist die Krise vorprogrammiert und heute ist die Zeit zu agieren.
Gut, vielen Dank, Rolf Densing. Hier war noch eine Frage, a question from Deutsche Welle. Of course, in English, no problem. Please identify yourself as well.
My name is Onkar Singh Janotti and I work for Deutsche Welle. And my question is how expensive it is to bring a non-functional satellite back and how much time does it consume?
Well, satellites, they come in all kinds and shapes. So if they are in low Earth orbit, you bring them back. You demise them in the atmosphere upon re-entry. If they are in geostationary orbit, you push them out to a graveyard orbit to clear a precious orbit. And how expensive this is, difficult to give a number, but one thing is for sure. If we want to keep space clean, if we want to take critical satellites out, it cannot be expensive because we need people to buy into it. So in ESA, we are sponsoring pilot missions in this respect, the so-called Clear Space 1 mission that we are financing with the help of member states, I must say, like DLR. And so those are pilot projects that we in ESA engage in. But we are looking to a routine phase thereafter. And this has to be, I would say, 2, if not 1-digit millions, because if this is more, nobody will use it.
Yeah. Okay, bitte, ja.
So the question of what's the cost clearly comes with a timestamp and when do you start thinking about it? It's the cheapest if that is part of your mission plan, and it's the most expensive when we have derelict space debris in orbit that nobody has taken care of so far. So I think the key is the earlier you plan for it, the cheaper it is. Even if you are out far beyond geo in the cislunar region, there are cheaper options to bring spacecraft back if we have enough time to plan for that.
I would like to add one topic. Coming back to this question of regulation, of course, the price tag is extremely important. And if you look into the past, into existing satellites, they are not cooperative. And to actually bring them down to deorbit these satellites from a technology point of view, it's very, let's say, demanding and it's very expensive. As Rolf Densing just mentioned, we have special missions where we try to do that. And ESA was actually the first space agency which came up with a mission, with a proposal how to deorbit an upper stage of a launcher in 2019 at the ministerial. But it becomes much cheaper if we use two topics. First of all, regulation and economy of scale. Because if we do not ask for actually external services by other satellites, if we ask the operators to actually implement deorbiting tools right from the beginning in the design of the satellite, then end of life will be initiated by the satellite or the operator itself, and this will be much cheaper. This is the power of a global regulation, and this is the reason why we strive for that.
Okay, thank you very much. Further question in the room. Bruno, please.
Hey, this is Bruno van Waaienburg, NRC in the Netherlands. So in the other session, there was mentioned that there was an exchange between an Aeolus satellite and the Starlink satellite. Could you, any one of you, provide any details on that? And the other one is, what is the status of the Clear Space project? Any updates that we haven't heard yet? Thank you.
Yeah, I can try both. So you are referring to an event that's a few years back, but which is actually template for what we see every day. And that was the encounter of Aeolus with the Starlink satellite, and that means 2 active spacecraft. Over the past, it was more usual that one active spacecraft has to avoid a piece of space debris, and then the action is pretty clear. The one that is maneuverable has to do the action. But as whenever 2 active spacecraft encounter each other, you have to rely on cooperation. You will have to communicate. You have to coordinate action. Only one has to move. If both move in an uncoordinated way, you might not solve the problem. So, but there might be different perceptions of the risk. So that's something where you would say, why are there not flight rules that make it crystal clear on who has to do what? And there are not. There are not at the moment. This is a manual task to get in touch between the 2 operators and agree on what kind of action to take. And that is still the case today. The only thing is we are better in automation now. And there are tools and systems coming up, by the way, also from startups in Europe, proposing solutions to automate and coordinate this as a service. But we are far away from a clear flight rule that would solve exactly the situation that Aeolus and Starlink had. Clear Space, the Clear Space mission is an active removal mission that we are undertaking as ESA. For legal simplicity, we are removing an ESA target. That makes it less complex, legal-wise. And this mission is indeed a pathfinder to help that removal of objects from space can actually be done, because no regulator will act if he doesn't see that these things work in practice. So for this to become the norm, we need to show it works, and that's the job of the Space Agency. The status of the mission is we have changed the removal target. It used to be an adapter of a Vespa stage. That adapter was flying in a very high altitude, and it was hit by a piece of debris, ironically, so that in the meantime we don't know in which state the object is. And for the very first demonstration mission, we found it's better that we do this in a safe environment. So we selected another ESA object, it's called Proba 1, flying in a lower orbit, where we are feeling a bit more safe with doing these critical operations. Because when we want to remove something, we want to make sure we are not adding more debris than we remove. And that's better done in a safe, low orbit where particles disappear very quickly. So launch is a bit delayed. We are now talking about the launch date in 2029, 2030 timeframe.
Okay, thank you very much. Yes, one more question. And then we also take questions from online. There are a couple of expert journalists also following across Europe here online. Please.
Yeah, my name is Sander Koenen. I'm writing for a Dutch magazine which is called Krag. 2 short questions. One, you mentioned that we are far from universal flight rules, as we have in, for example, civilian airplanes. Money was mentioned, technology was mentioned. What would you say is the 1 or 2 main obstacles to achieve global flight rules? That's one. And the second one is, if you had to prioritize, should we pay more attention to prevention or to active debris removal, and why?
I like these questions. Thanks a lot. How do we come to flight rules? My experience is, and I think it's shared by many agencies we are working with, is that a good standard comes out of the practice. So whenever nations that are really active spacefarers and have frequent encounters with each others, they will automatically come to a de facto standard on what kind of information needs to be exchanged and what kind of way out there is most pragmatically. And these standards, de facto standard established among few, but among important ones, is very often shown to be also become a common practice later on. And when this is established, the only thing is for regulators to pick up a common practice and make it a law. This has happened already because all the debris prevention rules that we have today, they have been developed by 11 space agencies, and if just a group of experts that found them technically workable and pragmatic, and they have been so convincing that they have been raised into what we see now in many national laws. And I think this can happen with the flight rules as well. I forgot the second question.
Prevention or active debris removal, if you had to prioritize?
Oh, these are two sides of the same coin. When you have to design a space system to reliably dispose at 100% likelihood, this will be unaffordable. Today, if you look at statistics, we reach a level of 70 to 80% reliability. So there's only an 80% chance that our systems actually can dispose themselves from space. That's why we say we have a technical problem. We really have a technical problem. We can, with additional technology that with the help of member states, we are investing with our primes, satellite integrators, to bring that to 90%. But that seems to be the point for the remaining 10%. They will be so expensive that active removal will actually become the more interesting option to cover these remaining 10%. And active removal being a technology that is not only appealing for the removal of debris, but also for extending the lifetime of objects. We can refuel them, we can use them in space a bit longer instead of throwing them away. So it becomes an economical factor that active removal helps us preventing space debris, actually. And when this is established and cheap enough, I think then we can also go and get some of the old targets that are there since many decades to get them out as well.
Well, if I can offer a simple answer. What is the obstacle? The obstacle is if you want to arrive at the space traffic regulation, you best do it through the UN, because space is global to begin with. The space business is very global, and if you want to pass regulation through the UN, you are sitting on the table with 100-some nations that all want to do spaceflight, and then typically you settle for the lowest common denominator, and this is a big part of the problem from a political point of view.
Add, in a very trivial sense, in order to do those rules, you have to know where everybody is. So we are still relying on getting the sensing input and exchanging the data, and also tracking those that do not exchange the data. So that is just the backbone of it all, and should not be overlooked.
Thank you very much. There were indeed a couple of questions online on the regulations, the law part. I think we have started answering them. Online, there was another question from Dirk Wagner from Hessischer Rundfunk. How could you rate the danger of in-orbit fragmentation events, exploding of onboard batteries or tanks in spent rocket stages versus actual collision avoidant events? And what can we do about it?
Yeah, I'm not sure if I grasped the question correctly. Both are an issue. So we do have on the order of 10 fragmentations still every year. That's an issue. Actually, 60% of the objects we have in space, they are a result of failed passivation. They are a result of explosions in space. So this is one of the biggest unmastered problems. How can we prevent our objects from breaking up? How can we make them really, really safe after the mission, that they stay in one piece? Technology, again, is the answer. Robust passivation means on board, fail-safe, redundant passivation systems. Collision avoidance and collisions. So probably the question targets at how severe is a collision as compared to a fragmentation. There's much more energy in a collision. So if a collision between two spacecraft occurs, the consequences for the environment will be by far more severe than an explosive breakup. The largest explosive breakup that I remember has caused 500 trackable fragments, but the Iridium Cosmos collision, which went into history as the most remarkable event in space, has caused more than 2,000 trackable fragments. So avoiding collisions is a matter that we need to invest in as well. But today, explosions are much more frequent than collisions. We have a collision every 5 years, but we have 10 explosions per year. So at the moment, two problems to tackle.
I would also add that for a number of fragmentation events, we still don't know the exact cause. Sometimes we do not know what is happening there. So that also points towards a technology gap. We also have seen that upper stages where best effort has been made that they were passivated have still fragmented and exploded despite the best efforts. So more research and technology insights are needed in order to tackle that problem.
Okay, thank you very much. Any further questions from the audience here? Otherwise, I'm checking online. There was one more question from Emma Gatti. It's more in the direction of space traffic management to Holger Krag. We are looking at an orbit that will need to accommodate 24,000 Starlink LEO satellites, plus the Chinese ones when they will be up. Is there any serious discussion on how the presence of so many Starlink satellites could and will influence the current debris situation? As she says, we are kind of avoiding the elephant in the room. Emma Gatti from Spacewatch Global.
And that's for me? Okay. The Starlink constellation uses an altitude of 550 kilometers. I say this because the altitude matters. The lower the orbit, the more quick the atmosphere will clean out these objects if they are not disposed. So there is a natural mechanism that helps us cleaning the environment, and that is our atmosphere. It decelerates objects and takes them out. And that is the case for the Starlink satellites. So there are really many, but if they are lost, they will be automatically gone within 5 years. That is just thanks to the low altitude they are using. Is that still an issue? Yes, of course. So many spacecraft are an issue because there are also other spacecraft flying in the same altitude, and one of them are ESA spacecraft, Swarm, A, B, and C, and we do have frequent collision avoidance maneuvers with them. So it's an issue for the short-term space traffic, absolutely. And there's another interesting aspect. Will any other competitor constellation use the same altitude? No, probably for that reason they will move into another altitude to avoid that. But that means are we sort of having possessions of certain altitude bands by acting in that way, which is a question I cannot answer, but I want to bring it up as a philosophical input.
Nevertheless, I would like to add one topic. Of course, the number of Starlink satellites is much higher than the others. Nevertheless, you can't come up with the leaks Starlink. You have to if you come up with a regulation, it has to counter everybody, and everyone is who's over there. And by the way, the second generation of Starlink will be bigger, and they will be also in a higher altitude. So if you come up with a special regulation for one constellation, it will boil down actually to it will boil down to a bunch of different topics and end up in chaos. There's only one sustainable solution for the topic, and this is a global accepted set of regulations. And so from this point of view, it's important not to look to Starlink or the Chinese. Germany or Europe, is coming up with a constellation as well. There's a question, okay, is this number so high that we have to have own regulation for them as well? This is a discussion which leads nowhere. We have to have a regulation applicable to everybody.
Thank you. I apologize for a little change in staffing. My name is Daniel Skook. I'm from the ESA Communication Department. Our colleagues had to depart exactly now together with the Director General, who is heading off on another set of media visits. But we will continue, and I know there's one more question at the back in the corner. Yep.
Gabe Board from the Deutsche Welle Science Unscripted podcast. I had a quick question here at the end. Do you think the world takes this topic seriously enough? And if not, what's the problem?
No. That's a very simple question, and it's a very simple answer for the question. No, it's not serious enough. I think that I try to get it across in my early statement when I thought that's a hidden grand challenge for us. And the second topic is why. It's simply because of, okay, maybe somebody else can take care of it. Because it's always a topic, let's somebody else do it, because if we start, we have the expenses. We have to do the research, we have the investment. It will boil down to more investments on our side to the benefit of others. So this is the reason why nobody wants to move, actually.
Just if I could get you to use the microphone just for the online viewers.
Sorry for the second question. I'm wondering how I'm going to get our listeners interested in this. Normal people. Why should normal people, if we can't stop polluting our own planet, how do we get people to care about space, I guess?
Well, actually, it's exactly that we show two topics. First of all, everybody will be impacted. Space infrastructure is the backbone of our modern society, and if this infrastructure is not working anymore, if we can't do any maintenance anymore for this infrastructure, our life on Earth will change. And this is what we have to get across, and this is difficult. It's very difficult because most of the people who have actually very limited insights that their daily life depends on space infrastructure. And this is what we have to do. We have to make them aware that without space infrastructure, our life will be different, much more complicated, and maybe not as comfortable as it is. And this is actually the base to raise the awareness that we have also to tackle the question of space debris. It's not just telling, okay, there's space debris, because as you said, everybody will say, okay, we have issues here on Earth, let's sort out these issues. If we start with this, it will not work.
Yeah, I just wanted to stress what he just said, because I think that the important aspect is to pass the citizen the fact that we are dependent on space, and even if we are not aware, everything we use on our mobile depends on space. Google Map starts from a geolocation, so it depends from a spacecraft. Weather forecasts are aided by spacecraft. Telecommunication now are through spacecraft. So if it's important that citizens are aware that we use the spacecraft in our daily life, and or we go back not to use it anymore, and now is impossible, or we need to make sure that as many other systems on Earth, we let's say we engage with this development, but to make it sustainable, for the future.
I think you can also view it from the perspective, I mean, no debate, space debris is not sexy, right? That doesn't sell. But what we do like to do is the space exploration. We like to do the cool stuff. We like to learn about our universe. And in order to do that, we just cannot ignore the space debris problem, because it's kind of biting us in the back and then invalidating all of those efforts we want to do.
Thank you very much. And I'll just see if there's another question in the room. And if not, there's one more question coming from online, coming from a journalist, Peter B. de Selding, who is asking, this was a question for Josef or Holger, and he was asking, the Zero Debris Charter differs from France's space operations law. will there be many differences between the Zero Debris Charter and the coming EU Space Act, for example, on the 5-year deorbit commitment?
We don't know much about the EU Space Act. That is a document still to be published, I understand, in a few weeks, but so far we don't know the content of the EU Space Act. The Zero Debris Charter is a forward-looking document. It's a document of an ambition that we would like to achieve in 2030. So it's not a charter applicable to what we do now. Why do we need this forward view? Because many of the rules that are in the charter require a development time for technology that we actually need in place in order to make this workable. Complex technology, like active removal, like passivation robustness, disposal robustness to 90%, and these kind of things. And that's why the level of ambition in the charter is higher than what you see in current space laws that are applicable right now, because they are setting the next step, because we need to prepare the technology in the background, and that needs some lead time, some long lead items.
Great, thank you, Holger.
No.
Good. I wonder if we're almost at the end, if there are any final questions, and I would like to invite our speakers, if you wish to make any final summarizing statement, anything that we didn't cover that you feel is important. I see nodding heads. Okay, I think we're okay. I would very much like to thank everybody in the media who joined us today. The replay of our web stream of this press conference will be immediately available very soon in the same YouTube channel where you're watching it now. We will be able to send you copies of the PowerPoint files to the existing media list. If you want to get a copy, please just send an email to media@esa.int and ask for that. Of course, our colleagues, our space debris experts, are remaining on site for today, so there's still lots of times and opportunities for interviews, one-on-one chats, although I think probably everybody is setting off for lunch, I think just right outside the door here very shortly. I'd like to thank very much the team here at the World Conference Center in Bonn who worked to produce our webcast and our technical setup here in the room. Thank you very much. I'd like to thank our speakers, of course, Thomas Reiter, Walther Pelzer, Holger Krag, and of course our two academic colleagues, and just so that I don't mispronounce the names, Carolin, Frueh, and Camilla Colombo. Thank you very much. Thank you.